first few problems ask us to find the measure of the angle or the arc indicated. So in 1A, we are solving for this arc right here. So that is a intercepted arc, and we first should check to see if we have the inscribed angle, and we don't. So then we're going to see what other information we can use. So we have an inscribed angle here. And we have an intercepted arc here. So what I'm going to do, and please note that there are many ways to do these problems. So the way that I'm showing you is just one way. So if I have an inscribed angle, 39 degrees, if I want to get the arc, I just multiply by 2. So 39 times 2 is 78 degrees. And then we can use the fact that there are 360 degrees in a circle, and I can do 130 plus 78. Which is 208, and then I can just subtract that from 360 to get the arc that I want. So 360 minus 208 is 152. All right, in B, we're solving for this angle. So anytime we're solving for an angle, we check and see if we have the arc, which I don't. However, I can use this other information. So I'm going to do something kind of similar that I did on the previous one. I have this angle. If I have that angle, I could multiply by 2 and I can get the arc. So 45 times 2 is 90 degrees. And then using the same information I used before, I can add these two angles together. So 148 plus 90, which is 238, and then I can subtract from 360, which is 122. So now I have the intercepted arc of the angle that I want. So now to solve for the angle, I'm just going to divide that by 2. So if we have the arc, we want the angle, we're going to do arc divided by 2. So 122 divided by 2 is 61 degrees. All right, the next problem, problem number 3, we're solving for this inscribed angle. So I'm going to look at the arc. I don't have the arc, so we need to use other information. Well, the only other information we're given is this 80-degree angle. So I'm noticing that this is a diameter, which means that we have a semicircle here, which means that FSD is 180 degrees. So 180 minus 80, that would mean FS is 100 degrees. So now I can use that information to get the angle. I would just divide by 2. So 100 divided by 2 is 50 degrees. So that would be the angle that we're looking for. All right, letter D. In this one, we are looking for this arc right here. And I'm going to see if we have the angle for that, and we don't, so we need to see what other information we can use. Well, the only information we're given is this 57-degree angle, which is this inscribed angle, so I can multiply that by 2. 57 times 2 is 114. And now that I have that, again, I see a diameter here. RP is a diameter, so I know that RQP is 180 degrees. So to get the arc that I want, I can just do 180 minus 114, which is 66 degrees. So as I mentioned, there are many ways to do these problems. I'm just showing you one way. There may be an easier way, but regardless of how you do it, you should end up with the same answer. All right, so now let's look at problem number 2. We're going to solve for x, and then we need to explain. So this problem seems like there's not enough information. However, we have a semicircle here, which means that that arc is 180 degrees. And to get the angle, I just divide by 2. So 180 divided by 2 is 90 degrees. That means that this angle is a 90-degree angle, so then I can solve for x by setting it equal to 90. So divide by 15 90 divided by 15 is 6. So to explain, I'm just going to put in some letters here. I'm going to call this A, B, C. I'm going to say since AC is a diameter, ABC is a semicircle and is 180 degrees. And then I'm going to put a point there, D. So angle ADC is 90 degrees since it's an inscribed angle. Okay, and that's all you really need to explain, because then your work here kind of shows the rest how you actually solve for x. Okay, so let's look at B. It's basically the same type of problem here. We have an arc, and we don't have the measurement. However, HK is a diameter, which means that this is a semicircle. So again, I'm just going to divide by 2. So 180 divided by 2 is 90 degrees since it's an inscribed angle. So then I could just set this equal 6x minus 6 equals 90, and then just solve it. So add 6. So 6x equals 96, and then divide by 6. X is 16. So I'm not going to explain this one again because it's basically the same explanation here except different letters. So HK is the diameter, and then you might want to add a point here. We'll call this point M. So that means that HMK is a semicircle, is 180 degrees, and then we divide by 2 since it's an inscribed angle. All right, let's look at number 3. So number 3, we're solving for TSV. So TSV is this angle right here. And there are a few different ways you can do this. So actually when I was making the key, I did this a different way that I think is a little bit of a longer way. But after looking at it again, I'm noticing that TW is a diameter, which means that this arc right here that I did in blue, that's 180 degrees. Well, if I'm just looking for this piece, and I know that this piece is 70 degrees, I could just do 180 minus 70, and that's 110 degrees. So the measure of angle TSV is 110 degrees. The other way you could do it, which is a little bit of a longer way, is to use the fact that these are vertical angles, and then solve for all the missing parts and then add them together, but I think that that's a little bit easier. So to explain, I'm just going to say that TW is a diameter. So TVU is a semicircle. And is 180 degrees. Okay, then the work basically explains the rest here, but we do need to explain basically where this, where this 180 right here was coming from. All right, let's look at B. So we're solving for YWU, which is an arc, so YWU. Okay. So again, there are multiple ways to do this, but the way that I see it is that there are 360 degrees in a circle. If I know that this angle is 105, I know that Y is also 105 since they're central angles. So then I could just do 360 minus 105, which is 255 degrees, and that's going to be our answer. So to explain this one, there's a couple things I need to explain. I need to explain how I knew that the angle and the arc were the same, and that's because they're central angles, and then Y I subtracted, from 360. So I'm going to say that YU is, or actually I'm going to say that let's call this, the center point is D. So angle YZU is a central angle. So arc YU is equal to the angle. And then I subtract from 360. Because there are 100, or not 100, 360 degrees in a circle. So in terms of explanations, as you can see here, I'm not looking for really long explanations. I'm basically looking for you to explain why you're subtracting certain things, and how you know central angles are the same and stuff like that. So basically explaining your work, but not really telling me what you are doing. So not saying, oh, you do 360 minus 105, but explaining where the 360 was coming from and how you knew why u was 105. All right, so now let's take a look at concept B. So concept B is equations of circles. So for this whole section, you are going to need to remember the equation of a circle. So it's x minus h squared plus y minus k squared equals r squared, where hk is the center. All right, so number 4, we're just writing the equation of the circle using the information given, and this one we're given the center and the radius, so this is the most simple thing we can do. We're just going to plug it in. So remember, when we plug in the center, because in our general form these are negative, when we plug them in, we're going to switch the signs of the center. So our center is negative 16, 9. So when we plug it in, it's going to be x plus 16 squared and y minus 9 squared equals 1 squared. So the simplified version would just be x minus 16 squared plus y minus 9 squared equals 1. Okay, and I do want you to write it after squaring the radius. All right, number 5, same thing. We're just going to plug in the center and the radius. So it's going to be x minus 2 squared, y plus 7 squared, because the sign switch, equals 2 squared. So that's going to be x minus 2 squared plus y plus 7 squared equals 4. All right, number 6, we're given the center and a point. So there's 2 ways you can do this. You could do it by plugging it into the equation here and solving for your radius. Or you could use a stack and count. So I'm going to show both ways. So first I'm going to show it plugging it into the equation here. So first, if we plug in our center, so it's going to be x plus 16 squared, y plus 9 squared equals r squared. And then we're just going to plug in our h and our k to our equation. So, or sorry, not our h and our k, our x and our y. So our point is x and y, and that's what we're going to plug in. So it's going to be negative 16 plus 16 squared. Sorry. Negative 19 plus 16 squared. Negative 9 plus 9 squared equals r squared, and then we're just going to simplify. So negative 19 plus 6 is negative 3. Negative 9 plus 9 is 0. So this ends up being 9 plus 0 equals r squared. So r squared is 9, and then take the square root. So the radius is 3. So now that we have that, now we can go back into the original equation and plug it in there. So it's going to be x minus 16 squared plus y plus 9 squared equals, and then we're going to square a radius, so 3 squared is 9. So you could, if you wanted, stop at this step, because you know you're going to square your radius anyways and plug that in, but I usually solve for the radius to avoid making any mistakes. All right, now let's look at number 7. So I'm going to show this one using stack and count. So using stack and count to find the radius, we're just going to stack our points, and we're going to count the distance between the x values. So between negative 5 and 1 is 6. Between negative 4 and 8 is 12. And then we're going to use Pythagorean theorem. So 6 squared plus 12 squared equals r squared. 36 plus 144 equals r squared. So 36 plus 144 is 180. And then to get the radius, we take the square root. Okay, so now that we have that, now we're just going to plug it into our equation. So using our equation of the circle, we no longer need the 0.18. We're going to use our center, which is h and k. So it's going to be x plus 5 squared plus y plus 4 squared equals the square root of 180 squared. So simplified, that's going to be x plus 5 squared, y plus 4 squared, and then square root of 180 squared is just 180. All right, number 8, we're going to state the center and the radius, and then we're going to write the equation of the circle. So first, looking at number 8, the center is going to be -2, -3. And the radius is just going to be 1. So using that information, it's going to be x plus 2 squared, y plus 3 squared equals 1 squared. So x plus 2 squared, y plus 3 squared equals 1. Okay, number 9. Again, we're going to state the center and the radius. So the center, that's going to be -4, 2. And the radius is 1, 2, 3. So now using that information, plugging it into the equation of a circle, so x plus 4 squared, y minus 2, because it's the opposite sign, equals 3 squared. So simplified, that's x plus 4 squared, y minus 2 squared equals 9. Okay, number 10, again, we're stating the center and the radius from the equation, then we're graphing the circle. So remember that the center is h and k, and we take the opposite signs. So the center of this circle is going to be -3, +2, because it's the opposite signs. And this is r squared, so if r squared equals 9, to get r, we're just going to take the square root. So the radius is 3. So now to graph this circle, we're going to first plot the center. So -3, 2. And then we're going to use the radius. So I'm going to go right 3, up 3, left 3, and down 3. And then I'm going to sketch my circle. Okay, number 11. The center. This is h and k, and it's the opposite sign, so it's going to be 1, -2. And then this is r squared, so if r squared is 4, taking the square root, the radius is 2. So now to graph my circle, I'm going to plot my center, so 1, -2. And then I'm going to draw in my radius, and then sketch my circle. All right, let's go on to concept C. So this is arc length and sector area. So looking at number 12, we're using arc length. So remember, arc length is x over 360 times 2 pi r. So we're just going to plug in to that equation. So x is the degree, and then r obviously is the radius. So using this equation, it's going to be 270 over 360, that's the fraction of the circle, times 2 pi times 15, the total circumference. And then we multiply straight across. So 270 times 2 times 15 is 8100. So it's going to be 8100 pi over 360. And then we go ahead and divide these numbers. So 8100 divided by 360 gives us 22.5 pi. So there's my exact answer. Then to get my approximate, so 22.5, we're going to multiply by 3.14, which is approximately 70.65 feet. All right, number 13. Again, we have our fraction of the circle, and then we have our radius. So plugging into our equation here, it's going to be 300 over 360 times 2 pi times 19. And then we multiply straight across. So 300 times 2 times 19. That's 11,400 pi over 360. And then we go ahead and we divide this. So divided by 360, we get approximately 31.67 pi meters. So there's my answer in terms of pi. And then to get my approximate, I'm going to multiply by 3.14. We get 99.43 meters. So remember, one of your answers, the smaller number is going to be the one with pi, so that's in terms of pi, and then when you multiply it by 3.14, that's when you get your approximate answer. And you don't write pi anymore because that's where the 3.14 is. Alright, so now let's look at the sector area problem. So for sector area, it's a similar formula. It's going to be x over 360. But since we're doing area, we multiply by pi r squared. So x represents the central angle, and then r represents the radius. All right, so looking at number 14 here, it's going to be 225 over 360 times pi times 19 squared. And just like the previous one, we are going to multiply straight across. So 225 times 19 squared. And you are going to get a big number. That's 81225 pi over 360. And then we simplify this, so divide by 360. You get 225.625 pi. And the units for that are going to be kilometers squared. So that is your exact answer in terms of pi. And then we multiply 225.625 times 3.14 to get the approximate. And you get 708.46. Okay, number 15, we have our central angle and we have our radius. So plugging into our formula here, it's going to be 45 over 360. That's the fraction of the circle times pi times 11 squared. That's the total area. So then we multiply straight across, so 45 times 11 squared is 5445 pi over 360. And then we divide. So that's 15.125 pi. And the units are inches squared. So there's my answer in terms of pi. To get my approximate, 15.125 times 3.14. Okay, you could always use the pi button as well. You should get 47.49. So I have my answer in terms of pi, and then I have my approximate answer. Okay, so now let's look at these word problems here. So number 16 says Charlie's riding a merry-go-round at Six Flags. The merry-go-round has a diameter of 35 feet. So I'm going to draw my merry-go-round, and the diameter is 35 feet. It says, how far does he travel when the merry-go-round has traveled an arc of 75 degrees? So if this is 75 degrees, we want to know how far have we traveled here. Well, the radius, we're going to have to divide the diameter by 2, which is going to be 17.5. Okay, now we have our angle and we have our radius. So using the arc length formula, it's going to be 75 over 360. That's my fraction of the circle times 2 pi times 17.5. And then we multiply across, so 75 times 2 times 17.5. We get 2625 pi on top over 360. And then we divide here, so divide by 360, about 7.29 pi. So there's my answer in terms of pi. To get my approximate, multiply by 3.14. So that's 22.90 feet. And then since this is a word problem, I do want to make sure we write a word answer here. So I'm going to say Charlie travels 22.90 feet. Okay, number 17, it says Callie is riding a Ferris wheel at the state fair. The Ferris wheel has a radius of 37 feet. How far has she traveled after traveling an arc of 95 degrees? So I'm going to draw my Ferris wheel. We know that the radius is 37 feet. And after traveling an arc of 95 degrees, we want to know how far has she traveled. So using my formula, I have my angle, so 95 over 360 times 2 pi times 37, which is the radius. So 95 times 2 times 37, 7,030 pi over 360. And then we divide. So we get approximately 19.53 pi feet. So 19.53 times 3.14. It's going to get me my approximate. 61.32. And since this is a word problem, I'm going to write it with context. So Callie travels 61.32 feet. All right, looking at number 18. So it says 2 adjustable angle pop-up lawn sprinklers have been installed in your yard. These sprinklers can spray everything within 6 feet. Given that the angle has been set to 85 degrees, how much lawn will the sprinkler spray water? Assuming the sprinklers do not overlap. So I'm just going to draw one sprinkler. So if this is 85 degrees, we know that it sprays everything within 6 feet. But remember, we do have 2, so we are going to multiply that by 2. So first I'm just going to find the area of 1. So 85 over 360 times pi times 6 squared. So 85 times 6 squared is 3,060 pi over 360. And then divide. So we get 8.5 pi. But I'm going to multiply that by 2 since we have 2. So 17 pi. And then to my approximate, 17 times 3.14 is 53.38. And writing my answer as a sentence, the sprinkler will spray 53.38 feet squared of lawn. All right, number 19, it says on a certain vehicle, windshield wiper is 25 inches long, turns through an angle of 165 degrees. What is the area of the windshield cleaned by the wiper? Okay, so in this case, we have a windshield wiper that sweeps something like this. The actual wiper is 25 inches long, and it sweeps at an angle of 165 degrees. So this is just a basic sector area problem. So 165 over 360, that's the fraction of the circle, times pi times the radius squared. So 165 times 25 squared is 103,125 pi over 360. And then we divide here. We get about 286.49 pi, and my units are inches squared. Then to get the approximate, 286.49 times 3.14. We get about 899.58 inches squared. So the windshield wiper cleans 899.58 inches squared of the windshield. All right, now the last page here, this is for segment lengths, inside and outside of circles. So since there's two problems of each one, I'm actually only going to explain one. But for practice, you should probably explain both just to get used to the explanations. So number 20, we're looking for the length of AB. So we should recognize that we're using the chord radius rule for these ones. So first of all, we need to draw in our triangle. So this is the triangle that we're dealing with, and it is a right triangle. And the hypotenuse of this right triangle is going to be the radius, which is 6 plus 3, which is 9. So my triangle looks something like this. So we're going to solve for x. So it's going to be 6 squared plus x squared equals 9 squared. So that's going to be 36 plus x squared equals 81. Subtract 36 from both sides. And then take the square root of both sides. So x is approximately 6.71. But since I'm looking for the length of AB, I actually need to multiply that by 2 because of the chord radius rule. So 6.71 times 2 is 13.42. So AB is 13.42. Alright, so now let's do B, and this is going to be the one I'm going to explain just because I have a little bit more room on this side. So again, we need to draw in that line there because it creates a right triangle that we can use. The length of our radius is going to be 15, so that's our hypotenuse. So using Pythagorean theorem, this is 9, my hypotenuse is 15. We're going to solve for x. So 9 squared plus x squared equals 15 squared. So 81 plus x squared is 225. Subtract 81. So 144. And then we're going to take the square root. So x is 12. But since we're solving for the length of AB, we need to multiply that by 2. So 12 times 2 equals 24. So AB is 24. So now to explain, I'm going to call this the center C. So I'm going to say since CB is the radius, it is 6 plus 9, 15. And then I'm going to say the next thing we need to explain is basically this, why we multiplied by 2. So the chord radius rule states that the radius bisects a chord so AB is 12 times 2, which is 24. All right, so two things you're explaining here. You're explaining how you knew the hypotenuse was 15, and then you need to explain why you multiplied this by 2. All right, so now let's look at number 21. So for this one, we are using the tangent to a circle theorem, which states that that is a right angle, which means that this is a right triangle, which then allows us to use Pythagorean theorem. Our hypotenuse is going to be 13, since we have to add 5 and 8. And now we're just going to use Pythagorean theorem. So 5 squared plus x squared equals 13 squared. So 25 plus x squared equals 169. Subtract 25. It's 144. And then take the square root. So x equals 12. So I'm going to go ahead and explain this one. So by the tangent to a circle theorem, the triangle is a right triangle. And then I'm going to call this AB. And I'm going to say since AB is a radius, it is 5 also. So the hypotenuse is 5 plus 8, which is 13. So two things we're explaining here. We're explaining how we know that that's a right triangle, which allows us to use Pythagorean theorem. And then we're explaining how we knew the hypotenuse was 13 and not just 8. All right, so let's take a look at B. Again, using the tangent to a circle theorem states that that is a right angle. And we're solving for this length here, which is a part of the hypotenuse. So first thing we're going to do is solve for the total hypotenuse using Pythagorean theorem. So 15.4 squared plus 7.2 squared equals c squared. So that's 237.16, and then 7.2 squared is 51.84. We add those together, so 237.16 plus 51.84 is 289, and then we take the square root. We get c is equal to 17. So that represents the whole hypotenuse, but we don't want the whole hypotenuse, we only want from here to here. So this is a radius, so we're just going to subtract. 17 minus 7.2 is 9.8. So I'm not going to explain this one because it's kind of the same as the previous one. Alright, so the last problems here, this one is using two theorems. So the first thing we need to do is solve for x. So 4x minus 12 equals 2x plus 12. This is using the tangent segments theorem that state if two lines are tangent from the same point, they're equal. And then we solve. So I'm going to subtract 2x. So 2x, and then I'm going to add 12 equals 24. And then divide by 2. So x is 12, and then we're just going to plug it in. So this triangle here, this is 12. So 4 times 12 is 48, minus 12. is going to be 36. So now I'm just going to use Pythagorean theorem. So I'm solving for AO, which is here. This is 12 and this is 36. So 12 squared plus 36 squared equals C squared. Then we add, so 1440, and then square root both sides. So it's approximately 37.95. So AO is approximately 37.95. So I'll go ahead and explain this one. So using the tangent segments theorem, AP equals AQ. So that explains this part. And then we need to explain well, actually we don't need to explain the tangent to a circle theorem because it already states that it's a right angle here. Had that not been drawn, we would need to say by the tangent to a circle theorem, we know that triangle APO is a right triangle. But actually in this problem it's a little bit easier because they already have that 90-degree angle drawn in, so you technically don't have to explain it because we already know it's a right triangle, which means we can use Pythagorean theorem. Alright, let's look at part B. So this one we're solving for the radius of the circle, which is right here. And we're actually given AO, but we're going to use the same theorem, the tangent segments theorem, to solve for x. So I'm going to subtract 5x and then add 3. So 2x equals 6 and divide by 2. So x equals 3. And then we're just going to plug it in here. So 5 times 3 plus 3, that's going to be 18. So now using my right triangle here, my hypotenuse is 21, this is 18, and we're solving for, we'll call it r because it's the radius of the circle. So r squared plus 18 squared equals 21 squared. So r squared plus 324 equals 441. Subtract 324 from both sides. We get 117, and then we're going to take the square root of both sides. It's going to be approximately 10.82. So again, the only thing you need to explain really is this. Using the tangent segment theorem, we know that AP and AQ are equal, which is why you know to set those equal to each other.